All right, scores earned on the mathematics portions of the SAT, a college entrance exam, are approximately normally distributed. Okay, so normally distributed with a mean of 5/16 and a standard deviation of 1/16. What scores separate the middle 90% of test takers from the bottom and the top 5%? Okay, so we are looking at this right here is 5/16, and I'm going to write to the side. My standard deviation is 1/16. Now it says middle 90%. Okay, so that 90% will go in the middle. Okay, so we can change that from a 90% to a decimal. So that's the same thing as 0.90. So that means that there's 10% left here and here. If I add those two little areas, these little areas right here, that is 10% left, which means that I've got 5% here. That's my bottom 5. And 5% over here. This is my top 5. And that's what they're talking about right here. It's separated from the bottom and the top 5%. Which we're going to change that from a percentage to a decimal. So 0.05, 0.05. Now what they're asking is, what are these scores earned? So we're looking for scores, which is really, we're looking for an x value. We're looking for this x value right here and this x value right here, which we'll call this one x sub 1 and x sub 2. So that's what we're looking for. So what we need to do is we're going to use this formula, z times sigma plus mu. I've got my mean, that's 5/16. I got my standard deviation, that is 1/16. I need to get my z-score, which they gave me this number right here. So to the left of this, we're going to find the z-score for this one, z sub 1. This will be z sub 2. If we're going to find the z sub 1, then the area to the left is right there, 0.05. So I need to go back to my z-score table and find that number, or something really close to that number. Okay, so we'll go back. And since it was below the mean, we need to go to the negative z-scores. So I'm looking somewhere in here for 0.05. Let's see. All right, now notice 0.05. That is halfway between this number and this number. And then I've got a little star right here. So I'm going to follow that arrow down. And it says right here, if I've got an area of 0.05, which I do, my z-score will be negative 1.645. Okay, so we'll go back. So for this one, it is negative 1.645. Now we could say, all right, since the normal distribution is symmetrical, well then this z-score is just the positive version of what I just found. Because our areas are the same, exactly the same on either side. So I could say that. Or what we could do is, so from this point right here, all the way over, if I get the area from that z-score all the way to the left, which means I'm picking up that 0.90 and I'm picking up that 0.05. If I add those two, then what I'm going to get is 0.95. That's the area to the left of z sub 2. So we could go back to our z-score table. Since we're above the mean, I need to be on the positive side. And you find the same thing. Between this number, and this number. Halfway between this number is 9.5. So you have this little star right here. You follow the arrow down. If I've got a area of 0.95, my z-score will be 1.645. Okay, which is what we just found. But we're not looking for the z-score. We're looking for the x value. Okay. So for x sub 1, I've got negative 1.645 times 116 plus 516. Or that's the same thing as 325. And we'll do the same thing for x sub 2. Now it's a 1.45 for my z-score, 116 for my standard deviation, and 516 for my mean. So x sub 2 should come out to be 707. Okay? So my answer for x sub 1, that is 325. There's my first answer. And the answer for x sub 2 is 707. That is my second answer. Okay? So what scores separate the middle 90% of the test takers from the bottom and the top 5%? Well, it's 325 and it's 707. Those are the two scores. Okay? Fast food restaurants spend quite a bit of time studying the amount of time cars spend in their drive-thrus. Certainly, the faster the cars get through the drive-thru, the more the opportunity for making money. That magazine studied drive-thru times for fast food restaurants and found Wendy's has the best time, with a mean time spent in the drive-thru of 138.5 seconds. Assuming that the drive-thru times are normally distributed, with a standard deviation of 29 seconds. So we can go ahead and say, all right, this is 138.5. And I'll put somewhere up here, my standard deviation is 29. What's the probability that a randomly selected car will get through the Wendy's drive-thru in less than 100 seconds? Okay. Well, 100 seconds we'll say is about right there. Now remember, this is an x value. We're trying to find what's the probability that it is less than 100 seconds. So that would be to the left of that spot right there. So what we need to do is first use a z-score formula. So x minus the mean divided by sigma. Now the reason we're using that is we're trying to find a probability of this over here. And since we're looking at a normal distribution, which is continuous, we know that area is equal to probability, or probability is equal to area. My z-score, if I get a number for this, that is linked to an area. Once I find that area, well, that area will become my probability. So that's the whole reason for finding a z-score. So this is going to be equal to 100 minus 138.5 divided by 29, which should give me a z-score. Should give me a negative z-score because I'm below the mean. All my z-scores are negative over here. All my z-scores are positive over here. So that'll give me a z-score of negative 1.33. And remember, you're always going to go to 2 decimal places if you're finding the z-score, because that's what this table gives you, 2 decimal places for every single one of these. Okay, so I need to find negative 1.33. So we'll go back here, negative side, negative 1.3 right there, and then I need another 3 right here. So where those overlap, is right there, 0.0918. Okay, that is the area to the left of that z-score. So my z-score at this point is negative 1.33. The area to the left of that z-score right here is 0.0918, which that's the part that we were looking for. So the probability that x will be less than 100 is equal to 0.0918. And that's your final answer right there. That's it. Okay, part B. Would it be unusual for a car to spend more than 3 minutes in a Wendy's drive-thru? Okay, if you go back, everything over here was in seconds, and now they're talking about minutes. So the first thing that we need to do is convert minutes to seconds. So 3 minutes, we'll put it over 1, and there's 60 seconds in 1 minute. Okay, my minutes cancel out. So I've got 3 times 60, or 180 seconds. Okay, so here's my mean. That is 138.5. If I add my standard deviation, so 138.5 plus 29, so that would be 167.5. Add it one more time, so 29 plus this number, that would give me 196.5. And you could subtract over here 2 numbers. 138.5 minus 29 would give you 109.5. 109.5 minus 29 will give you 80.5. We are looking for 180. Okay. So that would be about here. Here's 180. Now remember, anything within 2 standard deviations. There's 1, there's 2 standard deviations. There's 1, there's 2 standard deviations. Anything within 2 standard deviations, we said is usual. Anything outside of 2 standard deviations would be unusual. On either side, unusual. Okay, so since this 180 fell within the 2 standard deviations, then we would say that it is not unusual. Because it asks, would it be unusual for a car to spend more than 3 minutes or 180 seconds in a Wendy's drive-thru? Well, we found that no, it would not be unusual.